3. So for 3 tangent to x minus root 3 equals to 0. Therefore, tangent to x equals to root 3 over 3. For tangent, there will be only one base angle, okay, only one base angle. And you have root 3 over 3, which is positive, okay, which is positive. So tangent, what equals to root 3 over 3? Pi over 6. So 2x must be pi over 6. You only have one solution. And x equals to pi over 12. The period. Okay, what's the period for this one? Period. Pi over 2. Okay, pi over 2 is the period. So the general solution will be x equals to the first base angle plus pi over 2 times k, where k belongs to z. Okay, important, k belongs to z. And I can say x equals to pi plus 6 pi k over 12. Okay, I want to make the same common denominator. And I will try, so the domain is negative pi to pi. Okay, domain is negative pi to pi. So I will from k equals to 0, x will be pi over 12, k equals to 1, x will be 7 pi over 12. If k equals to 2, x equals to 13 pi over 12. Okay, 13 pi over 12 is out of domain, out of pi. So I'll stop here and going backwards. K equals to negative 1, x equals to negative 5 pi over 12. K equals to negative 2, x equals to negative 11 pi over 12, which is still alright. K equals to negative 3, x equals to negative 17 pi over 12. Can't have negative 17 pi over 12. So your solution will be x equals to negative 11 pi over 12, negative 5 pi over 12, pi over 12, 7 pi over 12. Okay, that's it. So list out those 4 solutions. Well, I will turn off the slide. Okay, we have solved a lot of equations for these 2 lessons. Okay, so in solving equation, there can ask 2 types of questions. One is, what is the general solution? Okay, what is the general solution? Second, we'll ask you, what is the specific solution? Okay, let's have a look. Let's have a look. We have the general solution for this question. The general solution is this one. Okay, the general solution is this one. I can also say the general solution is negative 11 pi over 12 plus pi over 2k. Okay, I can also say that's my general solution. I can say any, like there's infinite many ways to write the general solution. I can choose any angle, okay? So see, I have 4 angles here. I can choose any of that and plus pi k. Or I can choose this one to say plus pi k. I can choose any value which is like correct and then plus the period times k. So when you see multiple choice, when you work out the 2 general solutions by yourself, okay, you work out one general solution, and then you see in the options, there's none of that. Again, just no answer same as your answer. So no option same as your answer. Therefore, you need to see which one is equivalent. Okay, which one is equivalent. You're trying to add period or subtract period for your base angle and to see is that match any angle there. Okay, so in multiple choice, when you write the short answer question, doesn't matter. Okay, whatever you write is correct. But in multiple choice, you must choose the correct one. Therefore, you need to adjust your answer, add or subtract period to try to match as the same as the options. Okay, so that can be my general solution as well. Have a look at the next one. Next one we have tangent a half x equals to negative 1. is negative root 2 divided by root 2. Okay, negative root 2 divided by root 2, negative 1. A half x equals to what angle that should be? Tangent what equals to 1? Pi on 4. Okay, not 0. Okay, that's the part like students always confused. Not 0. Tangent 0 can only be 0. Tangent pi over 4 is 1. I want negative 1. Then must be in the sine quadrant because I only have one base angle. This reference angle needs to be pi over 4. And the actual big angle here will be 3 pi over 4. Okay, the actual big angle here is 3 pi over 4. So that gives me 3 pi over 4. And my x will be 3 pi over 2. What's the period for this graph? Yep, pi over a half. That's 2 pi. Okay, pi divided by a half. That's 2 pi. So period is 2 pi. My general solution will be x equals to 3 pi over 2 plus 2 pi k, where k belongs to z. Yes, that's 3 pi plus 4 pi k over 2. K belongs to z. Okay, domain is 0 to 4 pi. Okay, 0 to 4 pi. Well, let's have a think. How many solutions you expected? Like the number of solutions. How many solutions you expected from this? No, don't calculate, just have a think. Well, 0 to 4 pi is 4 pi, right? The length is 4 pi. And the period, how much is the period? Period is 2 pi. Okay, there are 2 periods in between 0 to 4 pi. There will be 4 complete cycles. In each cycle, there will be 1 answer in tangent. So I will expect 2 answers. Okay, it's 2 answers. Well, if you saw 4, that's definitely wrong. Okay, so 3 might like say correct, you need to check it. Like 2 will be very correct. Let's say when k equals to 0, x will be 3 pi over 2. When k is 1, x will be 7 pi over 2. That's 3.5 pi. Still within the domain. The next one is definitely outside the domain. So k equals to 2, 11 pi over 2. That's 5.5 already. We don't have that. Go for negative side. K equals to negative 1. X equals to negative pi over 2. Well, negative? No. So I only have 2 solutions. 3 pi over 2 and 7 pi over 2. Well, if there's a sine graph, if say there's a sine graph, you have 4 pi as the length. Okay, domain length is 4 pi. And the period is 2 pi. Then you will have 2 completely cycle there. In each cycle, there will be 2 answers. So you will expect 4 solutions. Okay, expect 4 solutions for sine or cosine. Okay, so there's tangent graph and tangent solving equations. And let's have a look at applications. Okay, application. It's suggested that the height ht meters of the tide above mean sea level on 1st of January is given approximately by the rule ht equals to 4 sine pi t over 6, where t is the number of hours after midnight. Okay, after midnight, 12 a.m. after midnight. Draw the graph. Okay, draw the graph of this. Okay, draw this. So remember, how do we sketch the graph? We sketch the graph by first think about the midline. The midline is 0 for this one. Okay, 0 midline. Maximum line is 4. The amplitude is 4. So maximum is 4. Minimum is negative 4. Okay, let's have a think. What's the period? Period equals to 2 pi over. Over is divide. So 2 pi divided by pi over 6. That's 2 pi times 6 over pi. That gives 12. Okay, 2 pi over pi over 6, like it's hard to see because there's a lot of fractions there. So I will divide by pi over 6 times 6 over pi, and that's 12. Period is 12. Okay, my step, each step will be 12 divided by 4 equals to 3. Okay, each step will take 3 units. Okay, each step will take 3 units. I'm using my way of sketching. Okay, so 3 units. Okay, and I want to find a starting point. To find the start point is always use pi over 6t equals to pi over 2. Okay, I want sine pi over 2 equals to 1. I want the bracket to become largest number, so pi over 2. Okay, t equals to 3. Okay, pi over 6 times 3 equals to pi over 2. Okay, and then I look this 4. The 4 is positive. So you will have a maximum point at 3. Okay, if it's negative 4, then I have minimum. Because it's positive 4, it's maximum. So I'll plot the graph like 1, 2, 3. We have this point here. Okay, go left by 3 units. You have just 0 here. Okay, it's just the boundary, like the domain. Okay, 0. Endpoints. And then I will have 3 plus 3, you have 6. 6 you have midline as well. And then another 3 have 9. 9 have minimum. 12 midline. 15 max. 18 midline. 21 minimum. 24 midline. Okay, and we have domain 0 to 24, so it's a day. Okay, we stop at 24, so that's for a day. Okay, I have, that's the shape of the graph. Okay, that's the shape of the graph. We must label the endpoints 0, 0. That's 24, 0. Maximum 3, 4. Minimum 9, negative 4. 15, 4. 21, negative 4. That's the shape of the graph. Okay, next thing is that when was the high tide? Okay, when you see it asking you when, it's asking you the time. Okay, like at 3 p.m., 3 a.m., it asking you the time. Don't say just t equals to 3 or t equals to 15. It's not correct. Well, it's correct, but it's not answer the question. It asks you when. It's like at what time of the day. So high tide is at 3 and 15. So that's at 3 a.m. and 3 p.m. Okay, 15 hours after midnight, 3 a.m. and 3 p.m. What was the height of the high tide? 4 meters. Okay, that's our maximum value. 4 hours. What was the height of the tide at 8 a.m.? Okay, at 8 a.m. So 8 a.m. is when t equals to 8. Okay, when t equals to 8. H equals to 4 times sine pi over 6 times 8. H is 4 sine 4 pi over 3. H is negative 4 sine pi over 3. Well, 4 pi over 3 is here. Okay, and then the reference angle is pi over 3. That's the tangent cotangent. So you have negative. Okay, negative sine pi over 3. Let's have a look at 8. 8 is about here, so it's negative. Okay, it's negative. You have a negative value. And then the height was, okay, what's sine pi over 3? Root 3 over 2. Okay, root 3 over 2. So that's negative 2 root 3. Okay, root 3 over 2 times 4 is 2 root 3. So it's negative 2 root 3. A boat can only cross the harbor bar when the tide is at least 1 meter above the mean sea level. When could the boat cross the harbor on the 1st of January? So 1 meter. Okay, 1 meter. Is that 1 meter? At least 1 meter. Okay. So 1 meter is here. Okay, it can go across at least 1 meter. So it will be, okay, I use this color. If you can find the intersection here, okay, and here, for this much time is above that 1 meter level, okay, and in between here is above the 1 meter level. Therefore, you just need to find the intersections. Well, but like I can't really solve that. That's 4 sine pi over 6t equals to 1. I can't really solve this by hand approach, so I need a calculator. Again, it asks you when. When, okay, it asks you when. So it asks you from 8 a.m. to 6 p.m., something like that, okay? So you need to first menu 3(1) to solve 4 sine pi over 6. Okay, I use x times x equals to 1. Comma x. Okay, never solve circular functions like that. You always need to set up a domain unless you want a general solution. You will have a general solution if you directly press enter. So you have the control equal sign to have the border and you restrict the domain. So it's from 0 to 24. Okay, 0 to 24. Well, control enter, you have like decimals. Well, if you not, okay, let's say we don't have that. See, there's 2 general solutions. There's 2 general solutions. It says 6 bracket times 2k pi plus whatever is that, sine inverse a quarter, whatever is that, divided by pi, or that. That's the general solution. Okay, that gives you the general solution. The N3 is k. Okay, it's the number k, it's the letter k. Same, you can use N or k. So let's have a look at our answer. We have 4 intersections. The first one is this one. Okay, I will copy that down. That's not 1 a.m. yet. Okay, that's not 1 a.m. yet. So I want to see how many minutes are there. So I will times this by 60. It's 29 minutes. Okay, it's 28.9 minutes. Like say it's 29. Correct to the nearest minute. So that's 29 minutes. So the first intersection is at I want a blue color 00.29 a.m. Okay, that's the when was it? It asks you when. Okay, so it's 0.48 hours after, but at that moment is 12:29 a.m. Okay, so a.m. in the morning. And the second intersection is that one. Well, the second one is after 5 hours and a little bit more. Okay, I will subtract the 5 hours first, and I want to see how many minutes are there. Times that by 60. 31. Okay, 31 minutes. So we will have 5 a.m. Well, 5:31 a.m. Okay, so in between these times, okay, 12:29 a.m. in the morning to 5:31 a.m. in the morning. Okay, in this period of time, the water is above 1 meter. Okay, the water is above 1 meter. And we can have the next one is 12 something here. Okay, I will minus 12. Okay, that's the decimals. I time the decimals by 60. Give you 29 again. It's symmetrical, okay, it's kind of symmetrical. It's after 12 hours and after 29 minutes. So this answer, I will have 12:29 p.m. That's in the afternoon. 12:29 p.m. 2. Okay, my next solution is 17.5174. Okay, minus that by 17 is after, oh, not by that much. It's after 17 hours already. And times that by 60. Okay, 31 minutes. So it's 5, after 17 hours is 5. Okay, and 5:31 in the afternoon. So 5:31 p.m. in the afternoon. Okay, it's symmetrical. You can see from your graph, it's exactly the same period of time, okay? It's after a period, after 12. So you will have that. That's the solution. Well, let's have a look at the next one. Well, next one is something not really important. It's something quite boring. Well, we just sketch the graph first. Okay, it's addition of ordinates for circular functions. Same as what we did before for the first chapter. Okay, addition of ordinates. Okay, just sketch the two functions first and then add the points. So let's sketch them first. 3 cosine theta plus sine 2 theta. So let's sketch 3 cosine theta first. Let's sketch 3 cosine theta first. Well, it's just stretched up by 3 units. Okay, the period is due to pi. So 3, 1, 2, 3 is here. And 3 is here. Okay, so 0 is the mean line. When theta equals to 0, you have the maximum value. Period for cosine is 2 pi. Okay, period for this, I'll write here. Period equals to 2 pi. So each step equals to pi over 2. Okay, period divided by 4. So pi over 2. So pi over 2, the next point will be the mean line. The next point will be the minimum. Okay, stop here, go that side. Mean line and minimum. That's the cosine graph. Okay, oh, that. Okay, that's the cosine graph. Well, somehow, why is it so ugly? Okay, that's better. Okay, that's the cosine graph. I have the point 0, 3 here, pi over 2, 0 here, and I have this point is pi negative 3, and negative pi negative 3, negative pi over 2, 0. Okay, the next one is sine 2 theta. Okay, y equals 2 sine 2 theta. Period for this one equals to pi. 2 pi over 2, which is pi. Each step is pi over 4. Okay, each step is pi over 4. Well, where I should start? 2 pi equals to pi over 2, theta equals to pi over 4. I should start from there. Okay, theta, sine pi over 2 is 1. So I should start from there. So I will have 1 is the maximum, the mean line is 0, the minimum line is -1. Okay, it's in between this blue graph. Okay, first step will be pi over 4. Pi over 4, I should have a maximum. Then each step takes pi over 4. Okay, from 0, it will go 0. Okay, pi over 2. Pi over 2 will be 0 as well. 3 pi over 4 will be here, and pi will be here. Okay, keep going that direction. You have minimum, that, maximum, and minimum. If you complete this graph, okay, some graph like that. Oh, I'm not 100% sure what the graph will look like, but let's say some point will be definitely there. Okay, let's just put some point which will be definitely there. Okay, see this first point. Okay, see this cross must be here. You have 0. Yeah, there must be a point here. Say the point must be here. The point must be here. And the point must be this. Okay, let's have a think. Okay, let's have a think between the two, between these two paths. Okay, from these two cross. Okay, from that point to that point. This is all positive. This is all negative. Where the graph will be? The graph will be in between, right? In between, like will be somewhere here or somewhere here. But let's say it's more negative. Can you see that's more negative? So you have more negative graph here. Okay, more negative graph here. So for this part to this part, your graph should be below here. And to see from here to here, okay, that's all positive. That's all more like negative. It's directly opposite. Can you see that's like symmetrical? So it's completely opposite. So that part will be here, and this part will be here. Okay, there will part graph and this part of the graph. So one below and this part is in between here. And from this to this, both positive. So you have like above that. You find something above that. And you have that to that is all below. So you have something all below here. So let's say we have something like okay, this green part. Well, it might not be exactly look like that, but it's reasonably correct. Okay, it's reasonably correct. Now all this part, okay, all of every point, the red one is more like higher than this one. So it must be all negative for that part, all positive for that part, because that is always higher than that. And for both of that is all positive. It must be go all above that and then go back to 0. For that, it's all negative. It's all go below and go back to 0. So it will be a reasonably correct graph. Okay, at least it's at the correct place. So you need to label this point, that's comma 0. You need to label that point, and that point. Oh, it's okay. Okay, it's already there, so it's at the 0 place, so you know that must be there. Okay, so just a little bit revision on chapter 1 stuff. Let's have a look for the last page. Okay, determine the rules for the graphs of circular functions. Okay, determine the rule for the circular functions. Okay, see the first question. A function with rule y equals to a sine bracket nt plus epsilon plus d has range of -2 to 6. Okay, what this can tells you? When it gives you the range, you can find two things already. What are they? Okay, mean line. You know your max, you know your minimum. You must know where's the middle. Okay, you know where's the middle. So you can find the mean line. Okay, so what is the mean line for this question? Where's the middle? Okay, like there actually I think it's easy, but like there's actually a lot of mistake happens here. Well, let's say that's the max. Your max is 6. That is your minimum. Well, max and minimum. Minimum is -2. Well, what's the total height here? 6, -2, what's the total? 8. Okay, so each part will be 4, right? Each part will be 4. So from here to here will be 4. From here to here will be 4. Okay, 6 go up by 4. What do you have? 2. Okay, the middle is 2. Or you can use the middle, like middle point formula, -2 plus 6 divided by 2, you have 2 as well. So first thing you know that is D must be 2. First thing you know is D must be 2. Okay, next, what's the amplitude? 4. Okay, already gives you from the midline go top is 4. So that's 4. Okay, but A is not 4. Absolute of A is 4. A can be -4. You don't know yet. You just say I can go up by 4 units, but that can be -4 as well. -4 can gives you go up, go down by 4 as well. So can't decide yet, and let's just put absolute A equals to 4. Okay, absolute value of A is 4. The next thing is period equals to 8. Okay, period 2 pi over absolute n will gives me 8. 2 pi equals to 8 times absolute n. Absolute n equals to 2 pi over 8, which equals 2 pi over 4. So I know another thing is absolute value of n is powerful. Again, n can be negative. Okay, n can be negative. I can say it's negative power 4x plus 3 or something. So we have that as well. And the last thing we know is when t equals to 2, y equals to 2. Okay, when t equals to 2, y equals to 2. Okay, one thing I want to tell you is for find sine rule and cosine rule or tangent rule, there's more than one possible answers. Okay, there's more than one possible answers because you can reflect by two ways, x-axis or y-axis. It depends on what you take for A, what you take for n. And also it can shift. It can shift like different units to give you the same graph. Okay, shift pi over 2 will be different to shift pi. So there's 3 like factors to change this graph. So there will be more than one combination which will be correct. So you just need to discuss that. Okay, you just need to discuss that a little bit. So we'll write D must be 2. A absolute can be 4. A absolute can be pi over 4. Let's say if y equals 2, I will take a positive of that, and I'll take a sign. I will take a positive of this n, and plus, I don't know what I need to plus, and I have that. Let's say we suppose that equation is this. Okay, it's one possible answer. I just need to decide what's my epsilon's value. Okay, that like small things value. And I know when t equals to 2, y equals to 2. So sub 2. Okay, in this particular equation. So 2 will equals to 4 sine bracket. Yeah. Oh, we'll have the d value as well. Plus 2. Yeah, 2. And sub 2. Is that 2? Yeah, 2. So pi over 2 plus that plus 2. Okay, that's 0, 0, 0. So 0 equals 2 sine pi over 2 plus that. Again, there will be more than one possible answers for that. Okay, the one thing I can see really easy is that can be this. Okay, pi over 2 minus pi over 2 will be 0. Sine 0 will give me 0. That's one possible answer, right? Or I can say that's 3 pi over 2. That's 3. No. Pi over 2. Let's say that's pi over 2. It's a positive pi over 2. Pi over 2 plus pi over 2 is pi. Sine pi will give you 0 as well. So there will be more than one answer which is possible. Okay, so I just can say one possible solution for that is this. Okay, it satisfies all the conditions. Okay, it satisfies all the conditions. Yeah, period is 8. Yes, maximum is 6, minimum is -4. Yeah, middle line is 2. When I substitute 2, it gives me y equals to 2. For this equation, it satisfies all the things they want. But there will be more than one answers. For example, I can write another one. It's this. It's still the same. Okay, still be the same. Well, I can also go for that. That's correct as well. That's a T. So, in other words, I can have y equals to plus minus 4, doesn't matter plus or minus, sine pi over 4t plus minus pi over 2, doesn't matter, plus minus pi over 2, and then plus 2. Okay, any combination will be correct. Any combination will be correct. I can take positive or negative. The 4 or negative 4 doesn't influence that. It will still give you the same max, same minimum. It will give you the same period, and it will give you when t equals to 2, y equals to 2 as well. You can try. Okay, I can try any combinations. You still have more, but I'm not going to show that. You still can have negative pi over 4 inside. That will be a different case. Let's have a look at next one. For this graph. Okay, this graph tells you that is y equals to capital A sine bracket t plus that. Okay, find the possible values for that. Okay, it's not say find all the values of that. So find the possible pair of values for that. First thing, the maximum is 0.5. The minimum is negative 0.5. Okay, so absolute value of A equals to half. Okay, let's go up. If middle line 0, so go up by half, go down by half. The absolute value of that is half. Okay. Let's say if A is positive a half, y equals to a half sine t plus epsilon. Okay, if I ask you to substitute a point, which point you will substitute in? Like you choose one. Okay, think one. Okay, think one first. If you think this one or this one, you will be wrong. Okay, do not try those two. Because when you sub the midline, as I said, when you really sub the midline, you don't know, you can't predict the next step. Okay, it can be up or down. So you can achieve an equation is totally this way. Okay, it's directly like reflect way. So put a maximum point or a minimum point will be the most safe method. Okay, always do a max or a minimum point to do the substitution. It will be the best way. Okay, so what I have in between, that must be the middle. Okay, it's symmetrical graph, sine cosine symmetrical graph. I have pi over 3 as one intercept, and the other one is this one. I will divide that by 2. I have 5 pi over 3 and divide by 2, so that's 5 pi over 6. Okay, 5 pi over 6 and a half. So I will sub even though this point is not labeled for us, but I know that must be this because I know the 2x intercept. So I will sub that a half. Okay, I will sub that in. So a half equals to a half times sine bracket t plus t is 5 pi over 6 plus that. So 1 equals to sine 5 pi over 6 plus that. Okay, sine what equals to 1? Sine pi over 2 equals to 1. Okay, I can say that's the thing. And epsilon will equals to 3 pi over 6 minus 5 pi over 6. That equals to minus 2 pi over 6, that's minus pi over 3. And that's minus pi over 3. But that also can plus 2k pi, where k belongs to z, or 2 pi k. Because it's not only one epsilon like satisfy. You can add another period on it. Okay, like 5 pi over 6 minus pi over 3 is already pi over 2. But I plus another period on it. That will be still the same position and still give you that value. But it's not really necessary. But I just want you to know that all this epsilon will be possible. Okay, all of this will be possible. So the pair of value will be if A is half, epsilon can be all of those values. Okay, that's one possible pair of answers. Okay, that's one possible pair of answers. Well, I can also have if A is negative a half, y equals to negative a half sine t plus that. Again, I still want to sub this point. So I will have a half equals to negative a half sine 5 pi over 6 plus epsilon. That's negative 1 equals to sine 5 pi over 6 plus epsilon. So what is negative 1? Sine what is negative 1? There's 3 pi on 2. So 5 pi over 6 plus epsilon needs to be 3 pi over 2. Okay, 3 pi over 2 is negative 9 pi over 6. And I can say epsilon is, that's minus that is minus 15 pi over 6 is minus 7 pi over 3. Well, wait, I'm doing that. That's positive. That's positive. That's not negative. That's positive. That's positive. Then I will subtract that by 5 pi over 6 is 4 pi over 6. 2 pi over 3. 2 pi over 3. 2 pi over 3. And again, it can plus 2 pi k. So k belongs to z. Okay, so for this pair, if a equals to negative a half, epsilon can take those values. You'll be two set values, okay? If a is negative a half, epsilon go for that. If a is positive a half, epsilon can go for that. You can choose any pair. Okay, any pair of solutions will give you the same value, same graph. Okay, same graph. Okay, why I say if you sub a maximum point, the next step must be correct? Because you know, like, your period is already settled. Okay, your period is already 2 pi, and each step you will take power 4 to go. Okay, it will be the same. And wait, I think okay, 1, 2. What's the distance between that? Yeah, 2 pi, 2 pi. Like 2 pi over 3. No, that's pi. Okay, that's pi. So 4 pi minus pi is 3 pi is pi. Okay, it's 3 pi. So that's correct. That's correct. So the period is settled down already. The period is there already. And then each step to go will be settled already. If you have where is the maximum point, the next point must be that one. Okay, if you know that point is here, then the next one must be the midline and take pi over 4 of the period. So if you know what is the maximum or what is the minimum, the graph must be correct. But if you sub in the middle one, the graph might be wrong. Okay, half of the solution will be wrong, half of the solution will be correct. So you can't take all of them. Okay, so that's finding solutions, and we finish all the circular functions. We go through really quick actually.